In today's stream, we're going to be building APIs with NestJS and Nx. We'll basically go over the blog series that I posted a few weeks back actually. In August, I posted this 5-article series. And I would love to have a recording of how I go over this stuff and do this. So, goal of today's live stream is to go over these 5 steps. First one's actually an introduction, so I'll skip that one. So we're starting off with setting up an Nx Workspace, then add NestJS to it, add GraphQL, and after that deploy it to Heroku. And we're going to see how far we can go in an hour. So I'd say let's go. Looks like we have a few people in the chat already. Welcome everybody. Really appreciate you following me here. So hey ho, let's go. If you have any questions, feel free to shout it out. And there is a delay, so I might see it a little bit later, but I'll try to keep an eye open on the chat here. So cool, let's go. So what I want to do here is basically execute the commands here, and while we're doing this, I can explain a little bit. So while we're waiting, I can explain a little bit what we're doing here. But first thing we're going to do is create a new Nx Workspace using yarn create, and we're going to call this BEEHIVE. So the BEEHIVE is my imaginary social network that I'm building out in this series. So you can see some more, you can expect some more. And so yeah, the command we'll be running here is yarn create Nx Workspace BEEHIVE, and what this will do, it will download the create Nx Workspace npm package, it will execute it, and it will create a workspace for me. Now, the workspace that I'm going to choose here is empty. So Nx has a few presets, but I'm going to pick the empty one. And we're going to add the NestJS package or plugin later. So we're going to use Nx CLI to power this. And we're going to enable Nx Cloud. Now this will set up a base project for me that we can then load up in my editor. So as you can see right here, it created the BEEHIVE folder. And inside this, it created the base project structure. So let's open it in WebStorm and see where we're going from here. Now this got created. It enabled Nx Cloud. We might go over that a little bit later. Let's copy the URL for now. There you go. So in here, the default Nx Workspace creates for us an apps folder and the libs folder, a tools folder for custom tools, and 2 important files here. One of them is the workspace JSON, where we can add several projects. Project can either be a library or a packet or an application. And it adds an Nx JSON. And the Nx JSON is where like Nx metadata is set. So for instance, here we configure the Nx Cloud, and later on we'll also get a list of reference projects right here. So let's see what's up next in the tutorial. After creating an Nx Workspace, we're going to create a GitHub repository. So what I'm going to do here is going to use hub create, and I'm going to create the BEEMAN/BEEHIVE repository. Now this is command hub I've been using for a few years now. It's super easy to quickly run commands in on GitHub, for instance creating a repo. And I need to make sure that I'm inside the project directory actually. So I'm going to do hub create BEEMAN/BEEHIVE, and this will go into GitHub, create the repository for me, and update my local origin. So now I have a project set up, GitHub BEEMAN/BEEHIVE, and following along with the tutorial, we can do git push origin master. I'm going to commit this change of Nx Cloud. configure Nx Cloud. Let's see. There we go. Configure Nx Cloud. And do git push origin master. There we go. And if we then go hub browse, we should see the empty repository right here. Now, one thing to mention is that I have my Git configured to use default branch main. So let's go here in NxJSON and change this default base to main so that it can know what my default branch is. Configure default branch in nx.json. There we go. Perfect. Now, with that out of the way, we have the basic project set up. It's set up with a repository on GitHub. And we can go ahead and do the following steps, which is configure Prettier. Now, Nx already has Prettier configured, but as you probably agree, there's few things more personal than code styling, and I'd like to configure a bit more than the default single quote true. So I shared my setup here. Open WebStorm, open Prettier ignore, and paste in my defaults. I'm going to say yes to this question. And then the next step here is reformatting all the code. Now, we don't have a whole lot of code in here. We don't have any apps and any libs configured, but just for good measures, let's configure this. Let's write it. Okay, no files were changed, that's fine. Now with these two, what I always like to do when setting up a new project is make sure that these Prettier rules are automatically applied. So in order to do this, we're going to use husky and lint-staged. Add those to the project. And husky allows us to define pre-commit hooks, or any git hooks basically. We're going to use the pre-commit hook, and we're going to have it execute lint-staged. And then, yay, new follower, thanks. And then lint-staged will be configured to run yarn format -- uncommitted when any of these files change. So yarn format is calling into an NX command that we can see right here. Sorry, zoom it in a little bit. And this is calling into NX format, which is exactly the command I just ran to format the whole code base. Now inside this package.json is also where we configure yarn, husky and lint-staged. So first one is husky. Set up husky here, and this will trigger the lint-staged. And in order for this to work, we need to configure lint-staged as well. So we go back to the tutorial, copy over lint-staged configuration, and paste it here. Now with this set up, if you take a close look here, when I'm adding the changes here, and when I'm doing a commit, so configure Prettier, husky, and lint-staged, you'll see that it will actually run a few commands here. It does the pre-commit, it runs some tasks. We now see it runs the yarn format of all the uncommitted files, and it will then do the commit. And with that out of the way, well, that's basically the step 4 that I'm doing here. Git add dot, git commit. Now I do a git push, and with that out of the way, in about 10 minutes, we finished the first tutorial. So that's great. Now, let's go over to the second step. The second step, what we're doing here is adding a NestJS API to Nx Workspace. And to do that, first we install the NestJS plugin, and we create a new application called API. So let's run this one. This prepares my workspace to do all kind of NestJS operations, like adding an application, adding a library, and recently a whole bunch of more things like adding a controller or adding a service. This is all pretty nice. I'll go over that in a next stream. I haven't looked into it yet. It just got merged like last week. So let's see. Oh, sorry. So with that, we now have the opportunity to call in the schematic that is provided by the Narwhal Nest plugin. And in this case, we will use the app schematic and create a new application called API. So let's see, this takes a little bit. It looks like my computer is still overheating a little bit, so I need to figure out if I can improve things there. So Chow is giving me a recommendation about the Prettier configuration, HTML white space sensitivity, setting it to ignore. Yes, I've seen this one. This is what generally reformats your Angular templates in a way that's not optimal. Let's say I'll make sure to keep that in mind and probably add it to my default config. So what we can see here in WebStorm is that inside package.json, it added a dev dependency. Should have added a dev dependency. Anytime now, I hope. And once that's in place, after running the schematic, it will generate the application here. Once we have the application, we will also, well, we first start it and make sure it works. And what we then do is add a core library. And inside this core library, I generally configure my configuration. So things like setting the port or setting the node environment or your database URL, I like to do that in a .env file. And NestJS has a very convenient wrapper around this, which is called NestJS/config. And this is what we'll be using here. Additionally, we'll be using Joy to do the validation of this package. So we have a strongly typed way of validating our environment variables with the option that it will basically tell us when things are not set. So we can go over the validation file, and in this validation we say, okay, the only valid values of node.env are development, production, and test, and this property is required. This makes sure that we always need to set this property, otherwise the server will not start. And this is a pretty convenient thing to have in your API, specifically if you have a lot of options in your env file. Now, finally, this is here, and this should have updated just package.json and yarn lock. So if we look at it, it just added the dev dependency narwhal nest and the additional entry to yarn lock. So let's now execute the command ng-generate narwhal nest, pick the app schematic, and pass in the name called API. This in turn will start downloading Nest dependencies, which are defined in the app schematic of the Nest plugin. It will download these, install them, and then scaffold out our application. I'm going to take a quick peek at why my computer is hogged down so much. Might very well not be happy with the rendering that I'm doing, the streaming that I'm doing, but yeah, it's OBS. That's hogging the machine down. So while we're installing dependencies, let's continue to check out what we're doing here. So we're using Joy for validation. As I said, node.env is now we can consider it basically strictly type. It will not allow any other variables, any other values for these variables. With these things all tied together, we have a CoreModule that has this configuration block, which we can then inject and use. And we'll supply a .env file with the default values. We'll also add it to gitignore, because that's generally best practice. These are files you don't want to check in to your source code. And then afterwards, once this is all in place, we will actually use this configuration service in our main.ts, which is the main initialization file for the Nest API. And we will get the value of the port, and we will get the environment. So we get a friendly message that shows us in which mode we're actually running our server. And this can be super handy for debugging purposes, so you get to see running the server in development mode. So let's wait a little bit to have these packages installed. And in the meanwhile, I can check the chat. Hey there, I see Dominique, I see Kerry. Welcome everybody. I'm super excited to have you here. Actually, yesterday's stream was the first one. It's available on YouTube, so if you cannot see it or you have to leave out at some moment, that's totally fine. You can always review them afterwards. Nice layout of terminals. Thank you, Jero Blacksmith. If you mean this, do you mean this shell command? If so, this is a custom configuration for C shell I have. It's out on GitHub. You can use it as well. You're watching it on the TV. Wow, that's awesome. The work laptop blocks Twitch. Yeah, they probably understand how us developers are. Z shell configuration that you have is available here on my server shell repo with a script to run it automatically. And if this is interesting to you folks, I'll happily do a session on how to customize shell and how we put this all together. Because this is, I think it's pretty important to have a good configuration for your shell. It can really help you speed up your work. Now, with that out of the way, we finally got my computer to create the API application. So when we do a git status, we can see that it created this apps API folder. It created a jest config and an ESLint-RC, because that's what NestJS depends on. And then it modified NxJSON, Workspace.json, and package.json. And in turn, obviously, yarn.log. So let's take a quick look at what it did. Inside Workspace.json, we can now see that it created a new project for us. Let's wait a second till it caught up. Well, let's go over the dependencies first. We can see that it now adds dependencies for NestCom and NestScore, Platform Express, and reflect metadata in RxJS, which are the dependencies of Nest. Then in workspace.json, we can now see that it added a project called API. And this project API defines where our API lives, what project type it is, and some things like the builder, which are Nx CLI's way to execute the build command, the serve command, the lint command, and the test command, etc. Builders are a super interesting concept, and they allow you to customize what you can do in your Nx workspace. So you can add a custom builder here and configure it. which also by itself is an interesting topic we can go over sometime in the future. For now, for this project, I'm going to stick with the default because this is exactly what we need. But yeah, this is a super powerful way to customize your applications and libraries inside an NX Workspace. Another file that got changed here is the NX.json, and here inside project, it also defines the API application. Now let's take a look here inside the apps API folder. We see it created a pretty default structure. If you have ever worked with an Angular app, you'll be familiar with this structure. It has an environment, it has an assets folder, even has an AppModule. This is very NestJS specific, I'd say. It defined a controller service, and this is the main.ts file. This is the file that actually bootstraps our Nest server. So this is the one that we'll, in a few minutes, be adding our development mode to. So that's that for the server. Let's quickly spin it up and verify that we can actually run this beast. So NX Serve API. This is NX CLI. Looking inside my workspace.json, finding the API app, and then firing off the serve builder, which is this one. And this executes the node command. It calls into the API build target, which is this one. And based on that, it knows that the main file is apps API source main.ts, and this is what's being executed right now under the hood. And scrolling back here to see if we're not forgetting any steps. After we've started the API service, it's time for us to generate the library. So we're here right now, step 2.2. After we generated the API, we're starting the server. And once it's running, we're gonna check out if this URL is returning the message down below. Let's already prepare this command. I'm using curl here to quickly get the output. There we go. It's really starting up now. My computer is really hogged down by OBS, so bear with me for a bit there. I hope to optimize this soon. To make this interesting for YouTube, I should probably record it afterwards or skip over these things. But there we go. It started up our API, and if we now run the curl command and call into it, we see welcome to the API. So that all works as expected. We're 2 commands in, actually, after doing the main setup. Now, next step here is to start the core library. So remember, NX Workspace divides your structure by default in 2 main types of projects. One is an API, which I consider like runnable apps. And then you have libraries, which add functionality to these apps and to other libraries. So with runnable apps, I generally mean everything that opens a port, that listens on a port. That's a general rule. There's some exceptions, but in most cases, something that you run as an application in an NX Workspace opens a port and listens to it. So that's a web server, a dev server, or in this case, an API. Now the library we're going to build here is going to be called Core, and we're going to include this one in API. Once that's done, we can add the configuration. And in a future follow-up series, I'm actually going to add GraphQL CRUD layer to this API. I think I'm going to go with a course setup. So my social network BEEHIVE is going to be all about courses. So we're going to have a course entity, which has a lessons model entity related to it. So one course has many lessons. And with that, that will be backed by a Prisma API. And after that, we can extend it, like add things like authentication. And once we have authentication in place, I actually want to follow that up with building an admin UI for this platform. So the idea is to have a whole full stack application built with NestJS in an Nx Workspace, database backed by Prisma, and an admin UI with Angular. Well, and if that's all in place, I'm going to check out like what would be a nice front end for it. Okay, so a question that Kerry asks, one thing I don't quite get, what does this buy you over using starter Nest Angular templates through Nest NG-CLI? And I think that's a great question. With this basic setup here that I'm doing, there's not a big difference, I'd say. It's maybe even making life more complicated than it should be. What I think where this really shines, this setup, is the extensibility that you get when you're building a bigger application. So for instance, the core library that we'll be building in a few minutes is a standalone library that I can reuse in other projects. So we could have a separate API. Let's say that we want to have a separate API for the front end. Front end APIs are quite a popular thing in bigger applications, bigger platforms. That way we can just share all the libraries. If we want to share it outside this project though, outside this monorepo, we can package up this library and push it to NPM and have it live on NPM and reuse it there. So for me, having the libraries in Nx Workspace is really a mental model for me, like treating them as NPM packages, treating them similar to NPM packages. So let's get rid of this one for a second. So the core library got created, and then we can see it here in workspace.json, got updated here. It got added to NxJSON. And one of the things you can do in Nest is add dependencies between these several projects. So we can then, this can be useful, for instance, to inform your linter, help your linter, instruct the linter which packages can depend on which other packages, which projects can depend on which other projects, I should say. For now, let's go over to here, libs. We see that core got created, and we have a default core module. Now, one of the things to keep in mind, if we go here inside our app module, we'll import CoreModule. So what we can do now is import CoreModule. And once autocomplete catches up, it will import CoreModule, and it will do so from the BEEHIVE/core namespace. So this is, for what the API is concerned, this is just another NPM package. It will use it in the same way. Under the hood, it's actually TypeScript that provides this for us. So inside TypeScript, in the compiler options, it added a line to the path object with the name of the package and the file that it points out to. So that means that everything that we export through this file will be exported as this package. Now, however, when we hit save, we will see that the API cannot resolve BEEHIVE/core. This is because tsconfig is not updated automatically in runtime. So we need to actually stop the server and run it again in order for TypeScript to catch up. And after that, we'll see that the API loads and that it actually starts this core module. It imports this core module because we defined it here in app. So that's step 3. We use the library, we import it here, We define it in the imports of AppModule. And then once this is loaded, we should see that this CoreModule dependencies initialized line is logged out. Now while we're waiting on the server to start, which normally is like a 5-second thing, but while I'm streaming, it's longer. While this starts, I'm gonna already install the NestJS config package and Joy. Joy is a validation library that I think is from HAPI or HAPI. I never know how you pronounce it. HAPI got changed, structure got changed, Joy got taken out and is now a standalone validation library. And in a bit we'll see how to actually use it, but for now we can see here when the API started that CoreModule is indeed loaded. So it took the module from our new core library and it loaded it there. So that's a great moment for us to add functionality to this core library and get validation up and running. Yeah, so Kerry says, makes sense. I've been mostly on multi-repo track lately. This is a cool approach though. I personally, I'm very much monorepo minded. I have a few projects that are not, and it has certain benefits. I think specifically in the realm of doing deployments, it's easier to have a multi-repo. It's easier to wrap your head around. It's easier to have a third-party person come in and work on it. Like, let's say you have an API with a mobile app and you want somebody to only work on a mobile app. It's easier to have that with a multi-repo. In most of the other cases, I think I prefer a monorepo. And I've been working with it since, I think, end of 2015, early 2016, where I was working on a JavaScript project. We used Lerna, and that was great. That really made me feel what it is to work in a monorepo and see the benefits. Then Angular 2 came along with TypeScript, and that made a whole difference. And suddenly my Lerna monorepo wasn't working that well. Luckily, in 2017, Jeff and Victor published Nx, and that changed the game really, because then I had the best of both worlds, the power of Angular CLI with schematics, etc., running in a monorepo, so sharing code between your apps, having schematics, and yeah, so that's really a game changer. Cool, so we installed the dependencies, NestJS config and Joy. Let's start and create configuration files. So I'm going to copy over this file name so I don't have to write it all out. I'm going to open WebStorm here, and in the root of my project, say create a new file, just a normal file, please, and give it this name. Now this created the file and the folder. It'll open it here, and let's copy over the configuration object. So configuration object here, it's actually a method that we're exporting. It's configuration method. It's a method that returns an object with 2 keys, environment and port. These both read into node-env. So using this actually already works, and you could just use this method, execute it somewhere, and then you'll have the value of node-env and port inside this object. However, this doesn't give you the validation. So we'll move over and add the validation file here. Let's just pick up validation.ts, create it in the same folder, validation.ts, and copy over this contact. So this is where we call into Joy, the validation library, and we tell it that it should validate this, create this validation schema where we say, hey, node_env is a string and it has these valid options and it is required. Then port is a number and its default value is 3000. Now, if you recall here, by default, the API that gets generated by the Nest plugin listens on port 333. And with this in place, when I now have configuration set up and it all works, we'll see that it'll automatically switch to port 3000. We'll see that in a second. But first though, now that we created the configuration object and the validation schema, we need to tie it all together. And the way to do that is to import the config module, and that comes from NestJS config, import configuration file and the validation schema, and load them into that config module. So we open CoreModule here. We add an imports key. And inside the imports key, I copied the imports key. That's so smart. We say config module, so now we generally want to import these things. And WebStorm was very helpful there. Now when we hit save, the API will restart, but it will also fail. And for those of you paying attention, which I guess are all of you, you'll understand why this is. This is because node-env is required, but it's not provided. So we don't have any node-env set, so server will fail here. There we go. And the error message is actually pretty declarative. If you look through, if you know where to look, and in production mode, you will not see this inspector stuff. So in production mode, you'll just get an error. Config validation error, node-env is required, which I think is a nice and descriptive message. So in order to comply to this requirement, we're going to go ahead and create the .env file in the project root, create .env, and pass in the two values that we got from the tutorial. Node-env is development, and in order for these changes to be picked up, we also, again, need to restart the dev server. Now, as I said earlier, it's best practice to not commit this file to source code, to your source control, to your Git repository. So we're going to go ahead and open gitignore and add the .env line here on the end of it. And another good practice when working .env files is for follow developers that use this library is to provide a .env.example. So we're going to go ahead and create .env.example. So the next person opening this repo, they at least have a clue of what the shape of this env should look like. And with these two things in place, our API should start, and it should listen to port 3000 instead of 3333. So we went over here and added the env file to gitignore and added an env.example. So far, so good. We're almost done with this part of the tutorial. So next thing we're gonna do here is open our main configuration file and use the ConfigService. Small note, we can see that listening server is now on port 3000. So it's no longer 3333. Let's open main.ts. So inside of our apps, inside apps API source main.ts. Now in here we want to bump up the font a little bit. We want to call into this config service, which will be importing from NestJS config. Spicy is dev. I have a new follower. Welcome. And what we're basically going to do is get a reference to this config service. So inside this bootstrap method, We're going to get a reference to this config service, and now we can use this config and call into any of the keys that we set in the configuration TS. So that's, in this case, environment and port. So we can say config.get environment. So the example here is provided, so we can say logger.log, call into the NestJS logger, and when all went well, we should see that it says it's running in development mode. So let's wait a second till the server restarts. Now the reason the port automatically changed is because here on line 18 we can see that the port is already calling into process.env. So the nice thing about using the .env file combined with NestJS config is that you can call into this raw environment variables right away. You don't have to use ConfigService, but it does give you the added benefit of being able to do validation on these things. So now we can see run in development mode. So that's, I think, a wrap for this tutorial. Yep, there you go. We're in the summary. So let's be good citizens and commit our changes here. So we actually have a feature, implement NestJS API and core library. There we go. Now, onto some more fun stuff, and we're going to add a small GraphQL layer. Now, bear in mind, this tutorial series for me was to have a nice base point I could refer to, so I don't have to explain these first few steps over and over again. Right now, I can just start an API and say, I'm going to build on top of this BEEHIVE starter project. You can find it here, and you can follow the tutorial here. So this is the reason I'm going to add GraphQL. I'm just going to add GraphQL endpoint with one method that basically returns the uptime of the server and going to deploy it. And then with that, I have a nice starter point to build my future applications on. So this is pretty similar. What we need to do first is install a few dependencies. So let's get that going. And then in the meanwhile, we'll go over the rest of the tutorial. So if we take a look at these dependencies, what we're actually adding here is the NestJS GraphQL library. We add GraphQL tools and GraphQL. So this is the GraphQL spec or library in JS, GraphQL implementation in JavaScript itself, and Apollo Server Express. Now, for those of you that don't know it, NestJS builds on top of Express.js. You can also have Fastify, but by default it uses Express. And for GraphQL, it builds on top of Apollo Server for Express. Now, this is the reason we have to specify it. If you have a NestJS server that would run on Fastify, you would have to install Apollo Server Fastify. So with this two being installed, we can already look at what the configuration looked like. Now, what we do here in step 1.2 is import the module. And as you can see, this is already in the core library. This is also in the core library. And I think you can start to see a pattern here is what I try to do in my workspace. I try to keep my apps as simple, as tiny as possible. I find it easy to have, and in a production app, I'll most likely get rid of the app services here and the app controllers here, and just have one main module that imports other modules that add functionality. And these other modules would all live in separate libraries. And this allows for a high level of reusability, and I think that's something we all can appreciate. So let's wait a few seconds. And while this is installing, I think I can already go ahead and prepare the import here. One second, please. So yeah, in our core module, next to the configuration module, we're defining the GraphQL module. Let's open core source lib, CoreModule, and this is where we will be loading it in. Just going to copy paste the snippet here and import it when the npm installation is done. Any second now. I'm really gonna fix my squeaky share. It was the one comment I had yesterday, like your live stream is nice, but your chair squeaks. So I'm trying to get some oil and put that in, like probably today. Normally doesn't really bother me, but tries to interfere with what I'm streaming about. So let's get an issue in for that and get it fixed as well. So this should be done anytime now. I'm just going to put this here already. The import. This will probably fail the server at some point, but it will work after this installation is done. Now, once this is all loaded, what we can see here is what we pass into the GraphQL module. So this is the GraphQL module for NestJS. And for those of you who are not familiar with GraphQL, GraphQL works with a schema. And in, let's say, the classic default GraphQL Apollo server, you need to define this schema by writing GraphQL schema definition language, which by itself is not hard at all, but inside a NestJS API, it's more idiomatic to write actual TypeScript and do these kind of things with decorators. So the NestJS GraphQL server provides two modes. It provides a schema first and a code first approach. And what we're working with in this project is the code first approach, which means that we define the GraphQL functionality inside TypeScript files and we annotate them with decorators. And that helps us to automatically build the schema file. And this is what the auto schema file option is for. A little bit later we'll see another option here, and we can actually already add it as like anticipating on this. In this for root module, we can configure more things about our Apollo server, and one of the things that we want to enable here is the playground. So GraphQL comes with a playground, super nice developer utility that you can use to inspect your API and interact with your GraphQL layer. And this playground is disabled by default in production mode. Now for this API, I actually want this API Explorer to be enabled in production mode. So I'm going to go ahead and quickly open the last page here in the series, which is the deployment to Heroku. And just to save us a little bit of time, because it would be nice if we can get it all done within the hour. If my computer is cooperating, we should probably get there. Now, as I said, this playground is disabled in production mode by default, but we can pass in the playground option and make sure that it works. So in order to do this, we tell our GraphQL module that we want to enable the playground by setting playground true. So we're going to take a step on doing that as well. So adding that in here, playground, set it to true. And this way it will not be disabled. Now, if this all saves and works, this is my poor computer. It runs CPU on 5,000%. It's all kernel task. Kerry Ritter said, I like it, it adds character. What are you referring to, Kerry? My computer being slow? Let's stop and start this beast. Now another thing I like to do, and this is not in this tutorial, it might be there. It should probably be there. When the server starts, I have this line listening on, and then localhost port / the global prefix, which is set to API. Now in order to quickly access our GraphQL endpoint, I'm going to copy that line and say, the squeaky chair. Yes, the squeaky chair adds character. I think I just need to figure out how to squeak the chair without talking through it, so you can hear either me or the chair. So added a simple line here that also logs out that we have a /GraphQL endpoint. And this can be handy when you run in debug. I'm sorry. This can be handy when you run your server and you want to just quickly access the /GraphQL endpoint or the playground. Now, lo and behold, this will actually not work. So what we've done here is instructed our CoreModule to load the GraphQL module. But GraphQL, per its specification, this is not a NestJS thing, but it's in the GraphQL spec, you always need to have at least one query. So if we look at the tutorial we were actually following, we can see that the server will now fail when it starts because it needs to have one query root type. Query root type must be provided. There you go. Error message again. That's good. That was expected. Query root type must be provided. Now, let's see how we do this. The concept in GraphQL is called resolvers. And you can kind of make a mental link that this is similar to a controller in the REST API, in the NestJS REST API, where you have a controller that adds /API /something, and you have various methods like get, post, update, delete, etc. In GraphQL, we have resolvers, and there's 3 operations. One is a query, one is a mutation, and the last one is subscription. Now in this series, we only look at the query. So what we do here, we create a simple TypeScript class. We decorate it with the resolver property. And inside this, we define a method called uptime that returns process.uptime. And we decorate it with the query decorator. And here we define which type it returns. Now uptime is a floating point, is a float. And we define this by returning a float. And these all come from the NestJS GraphQL package. If you're doing this on your own project and you're using autocomplete, make sure to import query from NestJS GraphQL, because query also lives in NestJS Common for the REST query decorators. Now, we need to register this resolver in the providers array, import it here, and with this, NestJS automatically generates the GraphQL schema. It informs our schema that there's a method called uptime, which returns a float. So now, with the server being started, we should be able to go to localhost 3000 /GraphQL. /GraphQL, there we go. And we'll be greeted with the GraphQL playground. And once that's there, we can see that we have one query defined here. And the query is called uptime. So we can execute query by using the query keyword, inform it to execute the uptime query, and we'll see, get a result back that our server has been up for 60 seconds right now. So that's it for this part of the series. I don't think there's any other steps we need to do. So yeah, we created the resolver, we imported it, and we registered, and now we can run this. That's great. So I'm gonna commit this change. Let's make sure that we made a few changes which are all expected. Add a feature, add GraphQL dependency and CoreResolver. Looks like I've typed that before. Now last thing, let's see if we can get this one running quickly. So what we're gonna do is deploy this beast to Heroku. And actually, because we're using very standard tools, we don't need to do anything special as long as we use the start and build scripts for our project. So what I'm gonna do is open package.json, add these two scripts, and with that, we should be ready to deploy it to Heroku right away. Now the build script, Nx build, so if you run npm run build or yarn build, this will not work. It needs a parameter, it needs to know what to build. So we're not losing out anything here. The start command, we're not really missing out on anything here either, because Nx serve, well, it will start the API in this project because it's the first project we generated. But we tend to be more specific and say Nx serve API. So it's perfectly fine for us to update these things. So we changed the build npm run build script to run nx build API --prod. And we changed the start script to say, hey, run node and execute the main.ts folder that's built in this app's API, which is where the default builds gets generated. Now with these two in place, this should work by default. So let's see, we can run it locally. I'm not going to do that to ease on my computer. We do need to run a local commit because Heroku works based on Git. So we're going to commit this change locally and then push to Heroku using Git. So we're going to say chore update run scripts. Oh, that's one. And now we're going to create an application. And so the BEEHIVE GraphQL application already exists. So I'm going to go ahead and check if I can create another application called BEEHIVE Live. Probably going to go for that. And then once that's in place, we should be able to do a push. So I'm going to create the app BEEHIVE Live. I cannot imagine that that already exists. I've reached my limit. There you go. I think I can delete. Yep, I can delete BEEHIVE-GraphQL for now. I'm just going to recreate it then. So going to delete BEEHIVE GraphQL. Going to configure it, confirm it, and then let's create the account BEEHIVE/GraphQL. And now it will be created. And then I'm going to say git push Heroku. I'm not going to do master because my default branch has been configured to be main. So I'm going to git push Heroku main. And now it pushes our main branch to Heroku and it will start to build. And one of the things you can see here, which is interesting, which is the reason why we explicitly configured Playground to be true, Heroku is set up to run node-env production by default. It also will not copy over our local.env file because it's inside our gitignore, which is behavior that's totally expected. Now, once this is running, we should be able to go to this URL, the BEEHIVE GraphQL Heroku app / GraphQL, and interact with our API and see this runtime. And so this should take a few more seconds. And with that, we should have a created and deployed app within an hour. Well, almost within an hour. It's 2 minutes past 3 here, so. But yeah, I'm super excited to be sharing this all with you, folks. I've been working with this stack for the biggest part of last year, and well, actually over the last year. Started like September last year with Prisma, Nest, and in an Nx Workspace, and I've really enjoyed it, and I thought it was time to share what I've learned. So this is one of the first live streams. It's all written out, as you've seen. It's all written out here in a tutorial form, so you can follow it all along. I'll share the repo on Twitter as well, so we can, I'll do a good push, git push right away. So you can download that and use it. Feel free to ask any questions. If you want to chat about this stuff, I'm super excited about it. Also, you can reach out on Twitter, but also on the new Angular Discord. So there's a new Angular community Discord that Steve and I started last Friday, and we have already almost 200 members. So that's super exciting. But yeah, feel free to chat there with me as well. Now, for the final verdict, let's see if this works. And it looks like it's loading, so that's all good. There we go. Query is already substituted. There you go. Uptime of the server, it's there. Perfect. Yay. Cool. Okay, and with that, people, I think it's a wrap for today. Thank you so much for joining the live stream, BEEMAN live stream BLS001. In about 2.5 hours from now, I'll be guest on Zach's live stream. We'll chat about Nx, NXPM, Nx plugin for Go that I did. I really hope to see you there. Thanks, everybody. Cheers.